y equals 1 minus 2t squared is a solution to y double prime minus 2ty prime plus 4y equals 0. Find the general solution. The differential equation is second-order linear homogeneous, so its general solution will have the form y equals c1y1 plus c2y2. Since we're given a non-trivial solution to the equation, y1 equals 1 minus 2t squared, we can use reduction of order to find the rest of the solution. Start by substituting y equals uy1, so u times 1 minus 2t squared, so y prime equals u prime 1 minus 2t squared plus u times negative 4t, and y double prime equals u double prime 1 minus 2t squared plus u prime times negative 4t plus u prime times negative 4t plus u times negative 4. So u double prime times 1 minus 2t squared minus 8t u prime minus 4u minus 2t times u prime 1 minus 2t squared minus 4tu plus 4 times u times 1 minus 2t squared all equals 0, which I'll rewrite as u double prime 1 minus 2t squared minus 8t u prime minus 4u minus 2t u prime 1 minus 2t squared plus 8t squared u plus 4u minus 8t squared u equals 0. As expected, all of the terms involving just a u cancel out, leaving only u prime and u double prime. So we have u double prime 1 minus 2t squared minus 8t u prime minus 2t u prime 1 minus 2t squared equals 0, or u double prime times 1 minus 2t squared minus 8t plus 2t times 1 minus 2t squared u prime equals 0, which simplifies to u double prime times 1 minus 2t squared minus 10t minus 4t cubed u prime equals 0. Next, we let z equal u prime and z prime equal u double prime to get 1 minus 2t squared z prime minus 10t minus 4t cubed z equals 0, which is a first-order linear homogeneous and therefore separable equation. We now solve the equation for z using separation of variables. Separating variables gives us that the integral of dz over z will equal the integral of 10t minus 4t cubed over 1 minus 2t squared dt. So the natural log of the absolute value of z equals the integral of 10t minus 4t cubed over 1 minus 2t squared dt. The right side is a bit tricky to integrate. Before we can integrate it, we need to rewrite it. I can tell that I need to rewrite it because the degree of the polynomial in the numerator is larger than the degree of the denominator. So I should do polynomial long division first. I need to take negative 4t cubed plus 0t squared plus 10t and divide it by negative 2t squared plus 1. Polynomial long division works just like regular long division with numbers. We start by asking ourselves, how many times does negative 2t squared go into negative 4t cubed? Well, it goes in 2t times, and then we multiply negative 2t squared plus 1 by 2t to get negative 4t cubed plus 2t, and write that result below so that we can subtract. So we can subtract to get 8t, then bring down the next term if necessary and repeat. But negative 2t squared doesn't go into 8t, so we're done. And the result is that 10t minus 4t cubed over 1 minus 2t squared equals 2t plus 8t over 1 minus squared. Now we can integrate 2t plus 8t over 1 minus 2t squared by splitting it into two integrals. And using substitution on the second integral, letting x equal 1 minus 2t squared and dx equals negative 4t dt, we get t squared plus the integral of negative 2 dx over x, which equals t squared minus 2 times the natural log of the absolute value of x plus c, which is t squared minus 2 times the natural log of 1 minus 2t squared plus c. So we now have that the natural log of the absolute value of z is t squared minus 2 natural log absolute value 1 minus 2t squared plus c. So we can solve for z by exponentiating and using the usual rules of exponents and logs to say that z equals plus or minus e to the t squared times e to the natural log of 1 minus 2t squared to the negative 2 times e to the c, which equals a e to the t squared over 1 minus 2t squared squared. Now that we have z equals a e to the t squared over 1 minus 2t squared squared, since z equals u prime, we need to integrate to find u. U is the integral of a e to the t squared 1 minus 2t squared squared dt. But there is no closed form antiderivative for this, so we have to leave the answer as an integral. So u will be the integral from t naught to t of a e to the x squared over 1 minus 2x squared squared dx plus some integration constant b. Finally, y equals uy1, so the general solution, messy as it is y equals 1 minus 2t squared times the integral, or you could write that as y equals b times 1 minus 2t squared plus a times 1 2t squared times the integral, which has the form y equals c1y1 plus c2y2 as expected.